Okay. So good evening. Yes. Today we are going to look at classes and object-oriented programming with C++. So last week we couldn't have the Google Meet, but we have gone through the video that we uploaded to you. So last week we did functions. Uh, We have declaring functions and then take accepting parameters, default parameters, multiple parameters, the return keyword, pass by reference, pass by arrays and function parameters. And we have what we call function overloading, that is having the same function name so but with different parameters. So today we are going to go through classes and object-oriented programming. So today we are in part 8, and we said today we are going to have a look at classes and then object-oriented programming in C++. So let's just define our main function here, as we always do. So we say we have classes and what? OOP. Let's have our first hello world. So let's compile this. Let's compile the hello world and see what we get. Okay, our code has compiled. So let's run it. We have our printed first hello world here, which is classes and OPP in C++. So today we say we are going to look at classes, object-oriented program. So first of all, let's define what object-oriented programming is. So we said it's a paradigm widely used in what game development due to its what ability to model complex system and what interactions. So in C++, classes are the cornerstones of what OPP or what we call or object-oriented programming. So in order to do object-oriented programming in C++, we use classes. So let's look at what um, classes are in what C++. So we say a class is what? Say the class is a what? Blueprint for what? Creating objects. Because in object-oriented programming, we have we have objects, classes. We create instances of classes which are objects in object-oriented programming. So we said a class is a blueprint for creating what? Objects. So these objects are also what we call instances of the class. So we call them instances of the class. That's what encapsulate data and behavior. So here we have method and properties. So the data is the properties, and then the behaviors can be methods within the classes. So first let's look at what data members are. So we say data members within what a class. So data members, let's just say data members are they are what? They are variables within what? The class. That store the what? The states of what? Of objects. So data members are they are variable that what? Within the class that store the state of what? Objects. So look at how we can create a class. So to create a class, first you have what? You bring the class keyword. Then what? The name of what? Name of what? Class. And then we have what? The curly braces. So this is how we create a class in C++. So let's see how we can create a class. So let's say, so to create a class, we have to create it outside of what? Functions. We don't create classes within what? Functions. So we have to create the uh, class outside of what? The function. So we say class player. So this is our class. We terminate it. So we say this is our class with what? Name player. So let's see how we can define data member within what? The class. So we have a data member here. So this data member we can say is a private. So private, um, later on we'll see what a private is and what a public is and what a protector is. So they are all part of the class. But right now let's see what data members are. So we have int health. So the health of the player. So this is an example of a data member. Yeah. So health here is a data member of what? The class with player. So this is how a data member is. So now let's see another definition here. Let me copy this and put them at the top here so that we'll have the definitions. So let's see what member functions do are. Member functions, or what we call methods. So in C++, a function inside the class is called what? A method. So we say these are what functions within what within the class that operate on the what objects or instances data, objects or data. So basically that's what member functions are. So they can manipulate the internal state and also provide an interface for interacting with what the objects or the class, the instance. So that's what basically what member functions are. So let's declare an example of what a member function is. So we have public and we have void. So we say take the image. So we define the image and we say how minus image. So I'm just decrementing the health. So this is what we call a member what function or a method. So it's a member function or a method. So the next this thing we are going to define is access what access specifiers. So we have access what specifiers. So what the access specifiers are keywords that are within what the class. So we have what private as we define here, private and public. And we have what public, private, public, and what protected. So what they do is they what they determine the visibility of what of the class what members. They determine what the visibility of what the class what members. So the members are this and some are this. So here we have what a private member here, which is a type of what integer, and the name is what help. As we define here, data members. We say they are variables within the class that store the state of what objects. So let's define each of this. So let's go with the private first. So we say the private members. So the private members are what only accessible only what within what the class within the class. So you cannot access them anywhere what else, only within what the class. And we say the public members are what accessible from what outside what the class. And then the protected members are accessible by what by driven class, or what we call inheritance, which we will look at later. So this one is only within the class. This one is outside the class, that you can access them outside the class. Any other functions or class can access them. Then protected members are only accessible by what classes that inherit what this class or this object. So here this this help is a type of integer which is what it protect a private. So this one is private. So in order to access this or make changes to it, we have to what? Have a public method that can what make changes to this private member here. So basically that's how classes works in C++. So let's see some of the object-oriented programming concepts. So first we have what encapsulation. So basically what encapsulation is bundling data and method that what operate on the data within a single unit or what class. So this hide the internal working of the class and provide a clear interface for um, interacting with it. So for example here we have encapsulated this member here. So this is an example of encapsulation. But we have what provided an interface here called what take the image that will what allow us to what interact with this particular what member. So for example, we can have another member here which we can say it will return an integer. So we say what get health. So we can make this one constant and we return what health. So if we want to access this private member here, we just create what a method to get it. Because it's private, no other function outside of this class will be able to what interact with this without what the public members. Okay. Or what we call the member functions. So this, as we said, these are functions within the class that operate on the object with data. So these methods are going to operate on this what data here, which we are going to be updating and what manipulating. So as we said in this example here, so we said what health is what encapsulated within the player what class, and we access to and the access to it is controlled by what the member what functions, which is what these two functions here. Take damage and what get health. So the users of the player class can only modify the health indirectly through what the what take damage method and what the get health method while maintaining what encapsulation. So that's basically what encapsulation is. So let's talk about inheritance. So as I already said, inheritance is a mechanism that allows a class to inherit what properties and what behavior from what other what classes. So it promotes code reuse and allows for creating specialized classes based on what existing ones. So for example, let's say we have a class. Let's define a class called. So let's define a class called character, and we have protected. So here we will use the protected keyword to see how it functions. So we have what health, and then we have public, and then let's define a constructor here int health, and we take what initial health. So let's call this int help. And take that one inside here. So later on we'll see what constructors are. Yeah, so we have a class with a constructor that take an initial help. So here we define a method with the visual. So here we have visual function here. So visual functions allow us to override what a method within what the class. Okay, they allow us to what to override what method within our class. So what basically uh, visual functions are, or how we override them, is you define the method, then later on you what add you declare or you set it on how it will be what used, how it should function. So let's have attack. So let's just say attack, and then we just say equals to 0. So this is what a pure what. So we call this a pure visual what function. This is a pure visual what function. So now let's create a class called enemy. So we already have it there. So let's create an enemy class, and we are going to inherit what the character what class. So here we have what inherited what the character class. So what we are going to do here is we'll add what we add the constructor for this. So we have enemy. Let's do the same thing here. So the same constructor here. We are what inheriting the super constructor from the what main the inherited class, which is character. So what we are going to do here is what we are going to override what this function that we have what all here, which is what attack. So we will what override it. So we add the override keyword here. Then we just say cout attack. So we say attack layer. So now we have what override this visual what function or visual method here, which is called pure visual what function. So now we have added our own logic here, which is a cout that we say should print what attack what player. Okay. So basically that is how inheritance work, and how we can create visual functions within our class and what override them with what inheritance. So here if we want to, we can what make this class player also what inherit what the the character class, so that they will all have what the same the same the same they will all inherit the same what method and what members. So they will all, if the player also inherit what the character, they will all share what the health and what the attack, because will have a health, and then the player will be able to attack the enemy, and then the same way that enemy too will have what a health and what be able to attack what the player in that order. And each of them too will have what different way of different way of defining what the attack function. So for example, let's bring this character class here. Let's bring it to the top here and just let's just inherit. Let's inherit the character class. So after inheriting it, what we can do it, we can remove this out or we can comment it because we don't need help again. We don't need it again because it's already defined here. So we don't need it and it's protected. So it's the same way as private inside this class. So because these ones are inheriting this, they will be able to what access this what protected what member data here. So we just do the same thing here. So under public, and then if one, we can just move all this all these functions here, and we can make all of them visually if you want visual functions or pure functions, so that each of them will what implement what its own functions for what each of these visual functions. So here let's just have what player constructor, and we'll take what the initial health that we already defined, and we take it from the superclass or the inherited class. Then here we can define the attack tool. So we override it. So one thing is this override we can omit it, but it will still work. So if you omit it, it still work. But the problem is if it's not a visual class, a function or visual member, and then you add the override to it, it will cause an error. For example, if we call this function inside the player class again and then we add override to it, we'll get what errors as compared to this a visual function. So basically that's how. So here we can say attack, we attack what enemy. So let's see what polymorphism is. So we say polymorphism is the ability for objects of what different classes to be treated as object of a common superclass. So this allows us to have more flexibility and generic code. Okay, so basically that's what polymorphism is. So having more than one different class. So we can say we have this character class, and then we can have as we have the enemy class and then the player class, both inheriting from the same thing. And we have what we call another um, concept we have in OPP is abstraction. So we say the process of abstraction is the process of what? Hiding the implementation details while showing all the essential features of the objects. So this one, what is basically does it just allow you to give someone the ability to interact with your code without knowing how or what is being done behind what they see in the code. So that's what abstraction does. So it just abstract what the data. So let's look at composition. So composition too is a concept of building complex objects by combining what simpler ones. So this can be achieved by what including instances of other class members within what a class. So that's what composition basically means. So all these things I will send a PDF so that you see all the explanations of these things in the details, and then I'll copy some examples of these codes inside the PDF. So you see how all these things are done. So basically that is just the introduction of classes. So let's see how we can create instances of a class and then use it within our function. So here we already have a class called player here. But for this, let's just create an example class that we'll be using to just interact with. So we call this my class, and we create our public members. So the public, as we said, public is what an access what modifier. So we said public here is an access specifier rather, or access specifier. So we have public, we have private, and we have what protected. So there are three access specifiers within what class. So let's define. So we say int age, and this is an attribute as what it's what variable. So I want us to use a string. So let's go to top here and add what the string class. If you want to know how you can work with string, one of these parts we have, I think is this here. Part 2 we have what look at how to work with strings in C++, how to manipulate strings and all those kind of things in C++. So you can look at it and see how to work with strings and all. So we define string here and we say name. Even this class, let's just send it to person so that it will make more sense. So inside our main class, here we are going to create what an object or an instance of what our person class. So we say person. So let me just take anyone name here. So person, person Anthony. So we say this is a person. So we have created what? We have created one on what objects or what instance of what the person what class. So now we have an object or what we call an instance of what the person what class. So basically that's how we can create an instance or object of what a person. So now we have Anthony. So we can say Anthony.age. We can say 10. We can say Anthony.name. say the name is something. So let's find this out. Person name, internet name, and then we have what the age. So person age, and we have Anton age. So let's compile this. No errors. So we run and we have what person name and then what age. So we have set them. So that's how we can what create what attributes or what members within what the class with what different what data types and with what access what specifiers. So let's see how we can work with what method within what a class. So here let's create another access, a private access specifier here. So we said access specifier, and we said what we have int, or let's make a string id. So id is an attribute of type string variable, and then we have a type of what access what specifier has what private. So we are saying here is that the user id should be what private, so that you can't just access it outside of the class or what manipulate it outside of the class. So let's see how if you want to what make some changes with this id or update it or get it. So we have what void, and say set id, and we take the id as a string. We said what id equals to what this id. So here we have what we are now able to what modify this what id here, and then let's see how we can get this id. So we have void get id, this one shouldn't be void. Let's make it string so that will return the id as a string. So return the id. So now we'll be able to what call these functions and what interact with some of this and make changes to this id that we declare as what private. So here you can say Anthony dot. So we have what this method set id. So we are setting the id to each. Then here we said what person id, and here we are going to what get the id. So this id, it will return a string. So we are going to get the idea and return it. So let's compile the next one. Okay, so this ID, what we have to do is we have ID equals to this ID. This is actually here there is a better way to do this thing. So like you can pass it as a reference. So I think here where is it? I think this functions here. Yeah, so we have this pass by what? Reference. So this pass by reference will what? Take the memory address of the value that we are passing through. Let's see these values. So we can what? Have the ability to what? Modify them. So for this one, we can also what? Pass it by what? Reference here. So if you want to understand how this thing works, you can go through the part 6 here. So where we have pointers and what? Reference. So you can see some of the examples that I've created here. Some of these examples here, where you can what? Use what? Pointers and reference to what? To set and what? To set what? Values. So what we have to do is just pass this by what? Reference. So here we have set ID. So we are going to just pass it by reference. Oh, I'm not printing the ID. Get ID. So this one should return the ID that we are having here. This is supposed to be passed through it, and then we print it out. So we pass the ID and we print the ID out. So I'm coming. Let's just say ID. Anthony. Oh, we can't have two IDs here. So ID string Anthony dot get ID. So we have ID string here. Compile. Oh. There's something that is wrong here. So we are setting the ID. ID. Oh, come on, come on, come on, come on. So here we have what? The ID here. Sorry, I think I just made the name. I forget that the name was the same. So it was just referring to itself. We could have used this one too. what do this, but it's not recommended. So let's do it this way. So we have what the ID here, person what ID. So that's how we can what set and then what get a private what attribute or what member within what a private what access specified. So now let's look at we have already defined constructors within these functions here. We already have constructors that we define. So let's look at what constructors are. So we say a constructor is a special method that is what automatical call when an object of a class is what created. So let me define it here. We say constructor is a special that is special, okay, special what method or function, method, okay, things like this. So we say a special method that is what that is automatically called when an object of a what of a class the class is what created is created. So that's basically what a constructor is. And to create a constructor, you use the same name as what the class, followed by what parentheses. So let's create a constructor here, a simple constructor here. So we said it should be the same name. So we say person. If when you can pass value to constructor, but here we are not passing any value. So we just define it here and say cout person, format it where person what constructor is called. So let's run this code and see what will happen. You see that before any object of the class or instance of the class is being called, the person constructor get called what first, because that is what constructors will do. They are the first things that would get called, and they are called. We said they are called what automatically when when the instance or the object of the class is being what created. So what we are doing here is when you create this, the constructor is what being what called automatically. So here that's where the what constructor is being called. So before we print out all any of this here, the constructor that we say should print out here will be the first thing to what will print out what already. So that is that is that is how basically how constructors should go. So they are like a certain stage that you can what put some values inside. So some values that you want to what initialize what first. So you can put them inside what, the constructor. So for example, if you want, we can what take take the age and then the name of the what the person before what we can pass a default value to them. So we can say int age default, and then we can have a string name what default. And we can have ID default too. We can have all of them. So here what we can do is what we can say age equals to default age, and then we can have name equals to default name, and then we can have ID equals to what? Default ID. So that's how we do. We pass what the values to what the constructor or parameters, as we call them in the last week this thing that we discussed about functions. So we said, so this is a constructor parameters. So we have passed a parameter because the constructor is also just a function as we define it. We say it's a special method. So method functions in class are called method. That is automatical call when an object of a class is created, or when an instance of what the class is what created is created. So here let's see how we can what pass these values inside. So you can see that we already have some red lines here because we need to pass what those what values here. We are not we didn't define them as what optional. So the first one we have is what age, which is 12, and then the name. So let's just make this one something like that. Let me see. Okay, this name. And then we have the ID. Say G 1, 2, 3, 4, 5. Okay. 6. So let's decide to comment this code. Let's comment this code and see what will happen here. Let's leave this one. So we need this. We need this one for this. So let's comment the others and see what will happen. Let's compile. You can see that we get what we still get values printed out. That is because we have what password the default what parameters to this what object or instance through what the class what constructor. So basically that's how you can pass what values to what the class what constructor. And this we can have different constructors within the class. So that's how constructors simple work. So we can have default values passed to it. But let's now go deeper into access specifiers as we already defined them. So we said they they what? We said that they show the or they determine what the visibility of what the class what members. So we have what, as we said, we have private, we have public, and we have what protected. And we say the privates allow members to be accessible only within what the class, and then the public allow members to be accessible from outside what the class. And we said protected make members to be what accessible by only what inherited classes or what driven what classes. So that's basically what the access specifier does. And then we talk about encapsulation. So we said encapsulation is to make sure that the data is hidden from what the user. So we are what hiding the data from the user, which we have done here with the private keyword. So here we have what encapsulated this. So we can say encapsulation, encapsulated, encapsulation is happening. So this part of the code we have what encapsulated it. We talk about inheritance here, which we define what a character class and make what player and what enemy to what to inherit from it. So now let's talk about multiple inheritance. Multiple inheritance. So let's have how would I do this? So we can have a class inherit what? A class that what also inherit what? Another class. So for example, we say class, we say father class. So we have father class. Let me put this thing here, multiple inheritance. Multiple inheritance. Let me drink some water. So we have a father class here. So we can just define as access specifier here for with public. Then we just say void other function. Other function. Let's see out for the function. Now let's declare another function called son. So just say class son class. Son class. So here we want the son to what? Inherit what? From what? The father. So we just say this, we just add say public father class. So we have inherited from the father. So we are doing multiple inheritance. So now this class is now called a drive class. So we have what we call drive class. And we say child. Then we have another, let's create another class here. And we call that one grandson. Right? Son class. And now we inherit from what? The son class. And then this one too is also called what? Drive class. But this one, instead of child, we say what? Grandchild. So now let's see where the magic happens here. So, multiple inheritance. So here we create instance of what? The grandchild. So we say grandson class, and we call it son. So we are going to call this grandson class. We call it gene class. And then we say gene dot what? Further function. And you can see that we are able to what? We are able to what? Import what? This class from what? So let's put this one public son, okay, grandson. So, okay. So we are able to call the function from what? The father class, because what? We have what? The son class inheriting from the father, and then the grandson what? Also inheriting from what? The son what? Class. So now what we are doing here is, let's say simple, say we are passing the genes from this what? Father to the son here, then to the what? Grandson. So there is one gene or one DNA passing through all of them. Okay. So that's why we are able to what? Call this what? Further function. So you see that we have what? Called what? The further function here. So that's basically how we can what? Do what? Multiple inheritance from what? For one class. So different classes can inherit from what? The same what? Class. So let's look at another way of what? Defining what? Let me add this thing here. So the further class here will become what? The base class. So we call this one base class. So the further class become what? The base what? Class. So here too we can have one class what? Inheriting from what? Different what? Classes. So this one, let's copy this and paste it here. Then let's call this one another base class. So instead of having a further class, let's change this one to mother class. And say this change this to mother function. So we have mother function. So now we can make this son class inherit from what? Both what? A mother class and a what? A father class. Yeah. So now let's define another class here. It says son2 class. Now we have public father, and then we have what? Mother what? Mother class. So basically what we are doing is we are inheriting from what? Two what? Different what? Classes. We call this derived class. Let me send this one down here. So now this class is able to inherit from what? Father and what? Mother. So if we create an instance of son2 class here, says son2, we say gene2. Now we can call this gene2. So we now have what? Two functions to call for this. So we can call the further function or the further method, and then we can what? Call the mother method too. So now this class have inherited from two different classes, and we can have more than that. We can even inherit from like three different classes. So when we run this, you see we have what? Father function and mother function. So now this G2 son have what? Inherited the father and then the mother what? DNA. So we have what? It have what? Inherited the father, and then it has what he or she has what inherited what the father DNA too. So it's just like passing down DNA to what the son. So we have you can use so let's see an example of how we can use the protected, even though we have already defined it. Let's see how we can use the protected what access what specifier. Specify. Okay. So here, let's create a class of called employee, employee, and we have protected member here called, let's make this double salary. So we take what the employee salary. So here we can create a class here. So this one too is a base class. So as the example we show here, that's how we declare the father and the mother. So let's create another drive class here. So let's call this drive class program, and we inherit from what the employee class. So in this employee class, a programmer class, we have another access specified. So we can have maybe the bonuses that the person receives, including the salary. So we can say we can create a method here that will allow us to access what the salary from what the protected salary. So we say this salary. So let's make it S. We are going to manipulate what the salary from what from the employee here. So protected is just like a private, but it allows what inherited classes what to have what access to it. Okay, so that's what protected is. But you can't still access what a protected member without driving from the base class. So here that's what we are doing. So we just say salary. It will automatically know that the salary is coming from what the employee class. So we set it. And now to get it to say double, the salary is double. Say get salary. And we return the salary. Simple as that. So now let's come here and create an instance of it. So we say program. Let me use someone name. Let's say Junior or Naya or something. Yeah. So we create an instance of this class called Naya. This programmer name called Naya. So now let's set Naya salary. So we say Naya dot what set salary. And we say you see $5,000 a month. Then his bonus is $1,000 per month. Now you can let me see. So now let's print out this values and see what we get. we say program select, get the select. And now let's get the bonus too. So we get the bonus too. So let's compile this and run it. So now we have what? The programmer salary and then what? The bonus. So that's how we can use what? The protected what? Value. So giving us the ability to add what? Private members and then inherit from the base class what? Private members and what? Modify them. So basically that's how you can use the protected keyword. So we already defined what a polymorphism is. But let's add one example of it so that we have a clear understanding of it. So we say polymorphism. And we say polymorphism means many forms, you know. So this like it occur when we have what many classes that are related to each other by what inheritance. Okay, just like how we have the father son this thing. But here we use it in a more in an example that would make more sense. So let's say we have a class called animal. So we define a class, call it animal. We spell animal. And we define a public specifier. And we said void animal song. So we are creating a method. Okay. Thanks. So here we have a method called animal sound. So we just see out there. We say the animal makes a sound. And so that is all for this class. Now let's create a derived class. So first we have a derived class called sheep, which is deriving from the animal class. And now we are going to override. So override the animal sound. Yeah. This is out. say the sheep says that is square. So we have what? Overridden this class. So now let's create another class, another drive class, and we call this one doc. We call this doc, and then here we say the doc says, or is it the doc back? So we have different for the doc. So now each of the animals have what inherited from the animal and the base class animal. So now let's come here and create an instance of the animal gen, we call this gen animal or generic animal, and then we have sheep, and we have dog. Now let's just say gen animal, print out the animal song. Obviously my sheep. Now we print out that too. And then my dog. So let's run this and see. So now we have what? Different animals, what making what different sound. We have the generic animal, but what we have what implemented our own what we have overwritten our own the function that is what the default function that is what inside the animal class. So if we didn't define this one, like this is what would have been called the animals, but we have created each class with its own what animal sound method. So that's why we have what each of them calling what they are what members. So time is up. We said 1:30, so time is up. I think we'll stop here then. Maybe tomorrow we'll see how we can work with files and then exceptions in C++. So any question? As I said, I'll be sending the PDF in with the written written document with this some of these examples. I'll screenshot and then add them there. Yeah. And then I'll also push the code to the Get repository, so that plus the PDF, so that you can access it online. We said part 8. So any question before we close for the day? Any question?